Hey guys, I'm going to go over 3 and 4 because they are two of the more challenging problems in the packet. So, battery lifetime is normally distributed for large samples. That's important because the normally distributed part of that is what tells you that you're going to have to use a bell curve. So, I think at this point, if I were you, I'd probably start off by just drawing a bell curve right now. Doesn't have to be perfect. But you're going to draw it because you may have to use it later. Make sure I go standard deviations in both directions. 3. Okay. The mean lifetime is 500 days, so that goes right here. And the standard deviation is 61 days, so this is going to be 561. This is going to be 439. And we may have to keep going after that. We'll see. Approximately what percent of batteries have lifetimes longer than 51 days? So that means I want to know all the people who are from here to the end, right? That section on. There are a lot of different ways to do this. I'll show you the 2 ways that most people have been doing it. So the first way is to take this piece and remove it because you know that that's not a part of this group here. So we can look at that middle section and say that that is 68% of the whole. So if we do 100 minus 68, we will get 32. Now what did we just find? Well, with that 32, we removed this section. So 32 is this, but it's also this. And remember, all we want is this section here. So if we look at these as being symmetrical, which we know that the whole thing is symmetrical, and we took the middle 68% away, this plus this is 32. So all we have to do is take 32, divide it by 2, and that will give us one of our sides, right? So 16%. That's one way to do it. The other way to do it, which is the way that I probably would have done it for some reason, everyone thinks differently, is I would have taken half. I know that this is half of my data, so that's 50%. All of this right here is 50% of the data. Now really I just have to figure out, I'm going to take this 50% and I'm going to add it to whatever this is, and then I'm just going to take that away from the whole. So what is this? Well, this is half of 68% because 68% is 1 standard deviation to the left and 1 standard deviation to the right. But really, in this case, all I want is the standard deviation to the right. So half of 68 is 34, and if I add those, I will get 84. So that's the area of all this, and I just have to subtract that from 100 to get this. So either way, you get the same answer. I'm showing you both ways because your brain might work like mine. It might work like the people who did it the first way. Who knows? All right, so that's number 3. Number 4, a test was given to 120 students, and the scores approximated a normal distribution. All right, I'm just going to drop what I'm doing, draw that bell curve because I know it's probably going to come into play. I saw that word normal distribution. If the mean score was 72 with a standard deviation of 7, okay, so we can fill in some of this stuff here. We may have to go further, who knows. What percent of the scores were 65 or higher? So I want from 65 up. Again, there are a lot of different ways to do this. You can figure out what this space is and just subtract it from 100, or you can add up all the spaces in between. Here's the way that I would do it. I would use the fact that half of this, so all this stuff to the right here, is 50% of my data. And I just have to add to that whatever this turns out to be. But we know from our percentages, from our rule, the 68, 95, 99.7 rule, that 68% of the data lies within 1 standard deviation of the mean. So half of that is going to be 34. So if I add 34 and 50, I should get 84%. Now the other way to do that is kind of the reverse of what we did last time. You could take the 68% here and say that that's a part of my group, and then you know that you have to add to that this section here. But to find that section, you just have to recognize that if you subtract 68 from 100, you'd be left with this and this, which is 32. So only one of those would be 16. So you'd add 16 to 68, get 84. All right, so hopefully that's helpful. This packet should do a pretty good job of preparing you for tomorrow's quiz. So good luck, you guys. Study hard, and I'll see you guys on Thursday.